A study was conducted to see if tagging penguins with metal tags harms them. In the study, 100 penguins were randomly assigned to receive a metal or an electronic tag, with the electronic being the control group. One of the variables studied is survival rate 10 years after they were tagged. Scientists observed that 20% of the 50 metal tagged penguins survived, 36 of the 50 electronically tagged penguins survived. First, we're asked if the conditions are met for using the normal distribution. What we need to be checking is if n1 times p1 hat, n1 times 1 minus p1 hat, n2 times p2 hat, and n2 times 1 minus p2 hat are at least 10. This would be the yeses and nos for each of these groups. So what we have for our values is a sample of 50 with a proportion of 20% or p1 hat being 0.2. So we're not given a count here, but just given the p hat. Second group, also 50, that proportion being 0.36. So if we plug these in, we'd have 50 times 0.2, which is 10. So we had 10 surviving. And then 50 times 1 minus 0.2 or 0.8, which is 40. So 40 not surviving for that group. Second group, 50 times the 0.36 is the number surviving, which is 18. And then 50 times the rest, 0.64, which would be the ones that didn't survive, which is 32. All of these counts are greater than or equal to 10, so our conditions check out here. We're supposed to define the population proportions P1 and P2. So P1 would represent the population proportion of surviving penguins with the metal tags. And then P2 would be the same, but for the electronics. So population proportion of surviving penguins with the electronic tags. So there's a test at alpha 0.05 or 5% significance level to see if the survival rate is lower for the metal tag penguins than for the electronic tagged. And so do the metal tags appear to reduce survival rate in penguins? So our null hypothesis will be that the difference is 0, or in other words, that P1 and P2 are equal. And then we want to think about what we're asked and which one we are naming P1 and P2 here. So when comparing these, we want to know if the survival rate is lower for the metal group, and the metal was group 1. So we're interested in seeing if this is less than 0 or if P1 is less than P2. So we have a left-tailed test. Before we can calculate our z, we do need one other number, which is our pooled proportion. Our pooled proportion takes into account the number of yeses for the two groups together. For group 1, we had 10 penguins. That was calculated up here. For group 2, we have 18 penguins. That is calculated here. And then the total is the 50 plus 50. So overall, what we end up with is 28 out of 100 surviving, or a proportion of 0.28. So our test at z is the difference in the two individual sample values, 0.2 minus 0.36. And then in the bottom, we use this pooled value, 0.28 times 1 minus 0.28, or you could put a 0.72 there, over 50. And then 0.28 times 1 minus 0.28. This one is also a 50. So our test stat is negative 1.782. And we're looking at a left-tailed test, so we're interested in this area here to the left of that number. So if we go to stat key and we click on normal and we do left tail with our test stat, we had negative 1.782. And so we get a p-value of 0.037, which is less than our significance level of 0.05. So for this test, we would reject the null and say we have significant evidence of HA. So that would be that the population proportion of surviving penguins is less for the metal tags than the electronic tags.